Various uses of earth wire. As I've already told you that earth wire is used to prevent from the electric shock. But how we get the electric shock? If suppose you are taking the electric iron and you are ironing your clothes, in that condition there are some chances for accidents to occur. Accidents mean the electric shock I am talking about. So how these accidents occur, let's see the probability. In that condition, what happens that if you are going to use the electric iron for long purpose or in some condition due to overload of current, the insulation of the wire melts. Then in that condition, the wire of the electric iron gets toned out or broken at some particular point. So these insulation when get broken or it get toned out, then the wire gets naked. And these naked wire, as I am talking about the live wire, because the live wire contains the heavy potential that is 220 volt. So when this live wire comes into contact with the metal casing of the electric iron or the appliance you are using, then in that condition that metal appliance gets the heavy potential of 220 volts. So that means that the electric iron which we are talking about or we are handling is in direct contact with the live wire, and the live wire makes that electric iron also live. Now in that condition, if you touch that electric iron, so you will get a heavy electric shock. So in order to prevent these accidents and this mishappening, the earth wire is provided. Okay, now before studying in detail about the concept of the earth wire, let's see that how you will get the electric shock. If you touch that electrical appliance, then in that condition the current from the appliance flows to us. And if you are standing on the earth's surface, then in that condition earth acts as a good conductor. So the circuit gets complete, and in the case of circuit, when it gets completed, the electric current flows through the human body and you become the part of the electric circuit. That's why you will get a heavy electric shock. Now if you wear any slipper or if you are standing on some insulator like wood, etc., then in that condition you will not get the electric shock. Why? Because as the current passes through the human body and when it reaches towards the ground, then it will not find any conductor, it will find an insulator. Then in that condition the circuit does not become complete and thus there is no flow of current and you will not get any electric shock. That's why it is advisable, your parents also told you to wear slippers, and that too dry slippers while touching any heavy appliance. Why I am specifically mentioning about the dry word? Because if you are wearing the wet slippers, then the water itself acts as a conductor and it will allow the current to pass from your body to the ground, and when the circuit gets complete, you will get a electric shock. Now let's see how this earth wire plays a very important role. In this condition, the socket which is provided for the electric iron or the heavy appliances consists of the live wire, the neutral wire, and apart from that the earth wire. This earth wire is connected directly to the metal casing of the appliance, while the live wire and the neutral wire are connected to the power plugs. But the earthing is always given to the metal body of the appliance. In the case when the live wire touches the metal casing of the appliance, then the current always follows the low resistance path. The earth has a zero resistance. So when the current passes through the metal casing of the appliance, then in that condition the current does not follow the path towards the human body, but it follows the path towards the earth wire. Why? Because the earth wire has a zero resistance as compared to the human body, and the current always follows the low resistance path. So when the heavy current starts flowing through the appliance, all the current passes through the earthing and goes to the ground. Thus it prevents us from getting electric shock. So this is how the earth wire plays a very crucial role. There is another appliance which we can say a safety guard, which is provided in our homes in order to prevent our electric circuit and our appliances. This device is called electric fuse. In our domestic electrical appliances, the electricity passes through the copper wire. This copper wire has a very low resistance. That's why it acts as a very good conductor and gives the passage of the electricity to pass through it. Now, as the current passes through the copper wire, then in some conditions, there is the heavy flow of current. What are these two conditions? The two conditions are the short circuit and the overloading. So, whenever the short circuit or the overloading occurs, then in that condition, the heavy current flows through the live wire and it may give the chances of developing a fire or a spark. Now, first let's see that how this short circuit is created. The short circuit is created when the insulator breaks down, and in that condition, the two wire gets interconnected. That is, the two wire touches each other. The live or the neutral wire touch each other. Then in that condition, the short circuit occurs. When the short circuit occurs, it follows the low resistance path. If there occurs a low resistance, then in that condition, heavy current flows. And due to this heavy flow of current, the copper wire cannot restrain it. And thus, it can produce a fire or a spark, resulting in the burning of the appliance. Now, next is your overloading. What happens in the overloading? You have seen sometimes that the extensions are provided in our home. Or in the case when we have one socket, then in that socket we use extensions, and many appliances or the heavy appliances are connected in a one socket. If you switch on the power supply in that particular socket, then what happens? That power appliances draws heavy current from the electrical connection, and because it draws the heavy current from the supply, then due to this overloading, the electric fire can occur. So, in order to prevent this short circuit and the overloading, the electrical fuse are provided. These electrical fuse, as I have already mentioned, is a safety device. So, whenever the heavy current flows due to short circuit or the overloading, then in that condition, your appliance will remain safe. How? Because the electrical fuse blows off. Whenever heavy current or the overloading takes place in the live wire, then in that condition, due to excessive heat is produced, which results in the melting of the fuse wire. As the fuse wire melts, so the remaining part of the circuit remains safe. Now let's see how the fuse looks like. Basically, the fuse has a fuse wire in between. This fuse wire is basically fitted between the metal cap. This metal cap is used to provide the electrical connection between the two ends, and the whole circuit is fitted inside the glass cap. Now, this fuse wire has a property that it has a low melting point and it has a high resistance. Due to the high resistance, large amount of heat is generated. And if the large amount of heat is generated in the fuse wire, then due to the property of low melting point, it will melt easily or it will melt before as compared to the rest of the copper wire. So, the fuse wire is constructed in such a way so that it can easily safeguard your power circuits. The thinness or the thickness of the fuse wire depends upon the current passes through it. The resistance is inversely proportional to the area of the wire. That is, if the fuse wire is thin, then in that case the resistance is high. If the fuse wire is thick, then in that condition the resistance is low. In market, if you go to purchase the fuse wire, then it comes in proper current rating. That is starting from 1 ampere, 2 ampere, 3 ampere, 4 ampere till 10 ampere and so on. So, depending on these current ratings, the fuse wire are available. If you take any fuse wire of low power rating, that is of let's say 3 ampere, then in that condition the fuse wire is thin. If you take the fuse wire of high current rating, like for example 6 ampere, then in comparison to the 3 ampere fuse wire, the 6 ampere fuse wire is thick. Nowadays, you can see that in many houses or in many buildings, offices, the MCBs are provided. What are these MCBs? The full form MCB. The full form of that is M for miniature, C for circuit and B for breakers. This MCB serves the same purpose as of the electrical fuse. But in electrical fuse, when the electrical fuse blows off, then in that condition you cannot repair the electrical fuse, you have to replace it. But in MCB, the switch is provided, which is called the MCB switch. So in case of overloading or short circuit, when there is heavy flow of current, then in that condition the switch of MCB goes down. And when you diagnose the fault and you repair the fault, then you can open the switch. So in this condition, you need not to replace it every time. You only have to switch on or off the MCBs. So as I've already told you that MCB is also a safety device. How it works? It does not work on the principle of electrical fuse wire. The electrical fuse wire basically works on the principle of heating effect of current. That is, when the current passes, the heating effect develops, and due to which the fuse wire melts. But in the case of MCB, it is basically based on the principle of magnetic effect of current. How this magnetic effect of current works in the case of MCBs? In this case, the electromagnet is provided. What happened that in the case of overloading, when the electric current increases, then in that condition, the strength of the electromagnet also increases. Due to the increase of the strength of electromagnet, it breaks the pair of contacts. These pair of contacts basically completes the electrical circuit in our home. But when the electromagnet gets activated or when the strength of the magnet becomes high, then in that condition it pulls off the contact towards opposite side. In that condition the circuit breaks and the circuit becomes open circuit, thus preventing the remaining part of the circuit from firing or any mishappening to occur. So this is how the MCBs work. The MCBs are provided at home, at offices, in buildings, everywhere in order to safeguard the electrical circuit. The electricity which we are discussing is a very important and a very dangerous thing. You need not to go around the electrical appliances. It causes lots of hazards and many accidents to take place. If the person happens to touch the live wire, then in that condition it produces heavy burns or it may cause death. So the case when the live wire comes in direct contact with the person, it produces a serious hazard. In the second case, I have already told you about the short circuit and the overloading. In both the cases, the heavy current flows through it. In this case also, the fire can trap the buildings, the offices, the home, etc. because the overloading of current melts the copper wire, and in this case, the heavy current flows causing the heavy fire across the buildings. Now, in the case of loose connections or improper wiring at home, for example, if the insulation gets worn out or there are loose connections or sockets in the home, then it also causes the sparks or the fires to occur. These are the conditions in which you will get heavy accidental burns. So, beware of the electrical shocks. So now let's see various precautions by which we can prevent us from getting electric shocks. Now, in the case if the person happens to touch the live wire, then in that condition you have the option to switch off the main supply. If the main supply switched off, then in that condition no current is drawn through any circuit and you can prevent the person from getting electric shock and serious damage. And you can also prevent from producing excessive firing in the home. Second is, if the person happens to touch the live wire and you cannot manage any main switch, then you need to provide the insulator to it. The insulator like wood, plastic, rubber, etc. This insulator stops the flow of current from the human body to the earth's surface, and thus the person can be prevented from getting electric shock. The third important precaution that you have to take, that never touch any heavy power appliance with the wet hand. The water is a good conductor of electricity. If you bring your wet hand in contact with any electrical appliances, then the current passes through your body and completes the circuit. And in that condition, you will get a heavy electric shock. Now, there are various methods also provided. For example, the earth wire. The earthing should be given to every heavy power appliances. The heavy power appliances which we use at home is always connected to the earth wire in order to prevent the heavy current flows through the human body. Because when the earth wire is provided, then the current flows through the low resistance path of the earth, and thus it prevents us from getting electric shock. Next is your fuse. The fuse is always there at home. I've already talked about it that instead of fuse nowadays we are using MCBs. So these fuse or MCBs are the safety device. It should be provided in our homes in order to prevent from sparks of firing. Because when the overloading of current takes place, then these devices get sacrificed. That's why it is called sacrificial devices. Now, in the next point, we need to check out the proper insulation and the proper thickness of the copper wire which we use at home. The wiring or the electrical circuits which is laid down in our homes or in building or in offices should be checked with proper sockets, with proper insulation, with proper thickness of the copper wire. Because if any of the circuit in case of any insulation get toned out or burned, then the serious mishappening could occur. So there are various precautions that you need to take while touching any electrical appliance. But my suggestion is not to touch any electrical appliance. If you need to touch the live wire, I am not talking about that you are going to touch the live wire. The electrician which comes to a house for repairing purpose, they need to touch sometimes the live wire. Then they shouldn't be touched with a naked hand. What they use? The insulators. For example, the rubber gloves, the rubber slippers are provided to them in order to prevent from heavy electric shocks. So these are some of the methods which can prevent us from the electric shocks and the serious hazards.